Welcome everyone to our talk. I am Alan Dipert. This is my longtime friend and open source collaborator, Micha Niskin. We're here to give a short talk about kind of the dark arts. Maybe some of you have seen Army of Darkness, familiar with the book, The Necronomicon. No, we're actually not going to talk about those kinds of things. We're going to talk about computers. In particular, we're going to talk about web application programming. So there have been more than a handful of talks about this topic. We're just another way to make web pages. So advance me there. Cool. There's our info. If you'd like to pull up any of our information right now, hoplon.io is the place to go to learn. Why are we interested in the Necronomicon? Dark spells, evil magics with the CK ending. Well, as web application programmers, we're looking at an increasingly hostile platform space. By hostile, I mean more complicated. All kinds of different deployment targets now. It used to be just, IE 5.5 on Windows XP, and it was good. Now it's, it needs to work on Chrome 33, Firefox 25, WebKit 2. Whatever. So we're facing a wall of complexity when it comes to platforms we're expected to deliver to. We're bad at estimating how long it will take to build any given application to target any particular set of platforms. I guess by we, I just mean me and Micha. He's worse than I am. But we're both pretty bad at it. And honestly, even the best developers, programmers I've ever met are usually off by an order of magnitude. Maybe 3 to 4 times. Not quite order of magnitude, but very few people are really good at estimating, even the best of us. So this is kind of scary. We don't know how long anything we do will take. That's weird. Why do people hire us? Once we do have something figured out, like we're happy with something, we've shipped it. Oh yeah, we shipped the app, works great, Android 4.5, awesome. Snowball or whatever it's called, ice cream. But then the next day somebody says, hey, does it work on iOS? It should. I mean, one's WebKit, the other both sort of WebKit based should work, but of course it doesn't because, one is a different aspect ratio or whatever. So now we're facing, again, this wall of complexity, and we are not able to estimate how long it would take to port one app to a different platform. So all of these battles you would think are easy ones to fight. Like, I have an existing app. I need to get it to work on a slightly different platform. No, it's not easy. It's incredibly hard. And to solve this problem, we need to look towards the dark arts, dead technologies. Spreadsheets are one of those technologies. Spreadsheets are not just notorious. I'd say spreadsheets are infamous. I mean, we've all had experiences with spreadsheets. They've been around forever. We kind of count on them or we see them as just a part of the computing landscape. This is an example of VisiCalc from 1979. This was the killer app for the Apple II. So that's what a spreadsheet looked like in 1979. This is what the spreadsheet looks in 2014. Anybody notice anything? Yeah, the colors changed a little. What is this like, though? Hit us, Micha. Patrick Stewart. Patrick Stewart has not aged. Neither have spreadsheets. They're the same thing. They have been forever. For all times, Patrick Stewart has been Patrick Stewart, and spreadsheets have been spreadsheets. Like Patrick Stewart, spreadsheets are amazing. They're an amazing technology, to the extent that Patrick Stewart is a technology. I should have thought about that slide. But they're both amazing. Unlike Patrick Stewart, a lot of programmers don't like spreadsheets. I don't know what it is. They have a long-time association with Windows and sort of business stuff that seems stupid. So we disparage them openly. I mean, honestly, it's rare that you run into a programmer who's like, dude, I'm into VB macros. Yeah, I'm talking a strange loop about VB4 macros and Excel 97. Cool. Like, you don't hear that. No. We think they suck. So we see them as an open problem, like something that we need to solve. Like the fact that we have a close friend who uses a spreadsheet. Like, let's intervene. I'm going to make this person a program. Like, I'm going to, whoa. Part of that is that they're not sort of computer science-y enough. There aren't really open problems around them. But the reality of spreadsheets are that they're what people use when we let them down. When we fail someone, when they come to us and say, oh, hey, what would it take to visualize these sale figures? And you're like, well, I need a team of 5, a budget of $3 million, and 4 months. You're like, OK, spreadsheet time. 20 minutes later, done. They're the technology that people go to solve their problems when we're not able to. So if we're going to learn from anything, I think spreadsheets are a great place to look. I took a stab here at describing, kind of taking a look at spreadsheets from the eyes of a programming language and environment. And I think spreadsheets are amazing for roughly these 3 reasons. I mean, they suck for a lot more, but for these 3 reasons, I think they're particularly incredible, and we should dive in. I think they're reactive out of the box. I mean, there's like a reactive manifesto now, and we're looking at FRP and all this stuff, but spreadsheets they've been doing reactive programming since 1979. So this is something pretty incredible. They're transparent. They're transparent in the way your program is transparent when you have a good debugger attached. It's easy to see, at least for some size of spreadsheets, what's going on. And finally, and I think most importantly, they're layered. They present a layered approach to computing that allows small groups of people and teams and businesses to work on each other, to extend each other's work easily in ways that we have a lot of difficulty doing with our programming constructs. So reactivity is the first thing I'm going to hit on here. This is a screenshot from an interview that Rich Hickey did with Brian Beckman a couple years ago. Ironically, at Microsoft, home of the spreadsheet. One of the things Rich says when the topic of the so-called epical time model comes up is that you can have a lot of semantics for managing time once you separate value from identity. So this is the separation that Clojure gives us, where we separate the name of something with the value it may have at a point in time. In spreadsheet world, we do have something like that, a reference type, if you will, that sort of fits into this worldview. You could get the slide. And that's the cell. The cell, in a lot of ways, and by cell I mean the little box in a spreadsheet where you type in a value or a formula, is one of these reference types. It's a reactive unit of time management. It's what gives spreadsheets this magical property of reactivity. The result of using cells in spreadsheets is that time does not exist in the spreadsheet. If anybody's seen the SICP lectures, they go 3 lectures without even mutating anything. And then suddenly, you define something a second time and time is introduced. Spreadsheets, there is no time. They are timeless and creepy, the same way Patrick Stewart is. They're transparent. So again, the spreadsheet interface is basically an incredible debugger. It's an awesome debugging environment. You can see the value of every variable. And when you change the values of these constituent variables, things change reactively. You can easily see what's going on. You have data, you have formulas, you have visualizations backed by either of those things. Just a great debugging. They're just a natural debugging tool. The third point I mentioned about layering, I think we can start to see here. So we're looking at a spreadsheet, and we've got a data grid, and then we've got a visualization. The incredible thing about what we're seeing here is that you can change attributes of the way the data is displayed, like those red horizontal bars. Maybe I want them to be blue, without interacting at all with the underlying data. Likewise, or symmetrically, I could change the data without changing the chart. And in fact, look at this next screen here. I mean, you can add new charts. You can have n charts, all different kinds of charts. Here I'm showing off the pie chart, which is probably not the one you want. But there are lots of charts, and we can attach them or plug them into this existing data and formula without changing the data or the formulas. And this is incredible power. So that's the tech. The sort of human side of it is that spreadsheets give us this natural boundary to divide labor. One person can enter the data. Someone who knows the business or knows what relationships to look for in the data can write formulas. And then others can make visualizations without necessarily writing formulas or entering new data. So what we see in organizations that use spreadsheets is these spreadsheets sort of circulate like trash around the oceans from different business units inside the company. And people tack stuff on. Maybe they'll want to use it for a report. Oh, maybe I have a better idea for how to do this formula. I mean, that's from a change management perspective, that's bad. But it's amazing from the perspective of everybody has a way to contribute something they're good at to this programming and this environment. So Hoplon, this web thing, it's a framework, a set of libraries that we've developed to work in Clojure and ClojureScript. If it's influenced by any one thing, I'd say that thing is spreadsheets. So at the heart of our framework is a ClojureScript library called Javelin. And Javelin is an abstract spreadsheet. It's a way to do spreadsheet-like programming in a ClojureScript environment. And our goal is to try and deliver all of the things that are good about spreadsheets to the ClojureScript programmer. So like normal spreadsheets, Excel 97, we have input cells. And one creates input cells by one of two methods. The first method is you can call the cell constructor. And this is just a function you call that returns a reference type of cell. This is similar to how you would create an atom or an agent or any kind of Clojure reference type. So here we're defining a thing to be the cell. Another way to make a cell with Javelin is we have a macro defc. And all that does is create a cell named n, and you don't have to type the constructor in. We just have this because our programs tend to have lots of cells. We have formula cells. Formula cells are different from input cells in that they shouldn't really be mutated. You don't change the contents of them dynamically, necessarily. What they do contain are ClojureScript expressions, which are analogous to the formula values in an Excel spreadsheet. So in this case, we're defining an input cell called n, giving it an initial value of 0. Then we're defining a formula cell called n times 5. And we're using cell equal, which is a formula cell constructor macro. That takes an expression. And at this point, we can dereference either n or n times 5, and we'll see values that are consistent. If we swap bang on n, incrementing its value, and then dereference n and dereference n times 5, we'll see that n has been incremented, and n times 5 is somewhat magically, but in that awesome spreadsheet way, reflects the value. And that's the value we established through our formula. The same way there's a defc, there's a defc equals. And again, this is just sort of having fun with macros little exercise. Javelin is different in, I think, some interesting ways from spreadsheets that you may be used to. The first and maybe coolest difference is that cells in a spreadsheet, like we have in Excel, can't take collection values. You can put numbers and strings, but putting collection values in the cell, that's not even really possible. So people have other mechanisms to deal with collections, like ranges and pivot tables. Cells in ClojureScript are not that way. Like any other Clojure reference type, that you can put any value in them, including other cells, functions. I mean, anything that's a value, which is everything in ClojureScript, can go in a cell. And the other difference is that unlike a spreadsheet's grid, the global scope of a spreadsheet is this 2D grid. The scopes and names in Javelin follow ClojureScripts. So you can create let-bound cells, cells that are only available inside a Clojure. You can have package cells in namespaces. So that approach that we take with Javelin is kind of similar to the way people work with sheets or worksheets in spreadsheet programs. So that was undead technology number 1, spreadsheets. The other undead technology, which we're probably more familiar with, is Lisp. Lisp, like spreadsheets, most programmers think sucks. Of course, we know otherwise. So I'm going to let Micha teach us some things about part 2.
Yeah, so HLisp is kind of the charting and forms, the charts and forms layer of the spreadsheet. A cool thing about spreadsheets is that given a spreadsheet that has formulas you might not even understand, you might be presenting something to the board of directors, or like on TV, somebody always has to make a report by Friday or whatever, and they have to stay up late. But what they're doing is they're taking the spreadsheet and they have a Word document, they're putting content in there, making graphs, things like that, and pulling them into their Word document that they're going to show to somebody to hopefully elicit some kind of action. And that's really what a web application is too, the UI of it. And so HLisp is that part of it, the charting part. So HTML, when you load index.html into a browser, the browser normally reads a bunch of HTML markup and loads it into the DOM. But this HTML is already a programming language. It's not a very good one, but it definitely is. Like the browser has to parse this HTML markup, which is kind of weird, and then it has to build a tree, and it has to walk the tree, create DOM elements, and put them in the DOM. And so luckily, thank God, so unfortunately, it doesn't have a means of abstraction. So there's no way to define something new in HTML markup. There's no access to the JavaScript environment, which was kind of bolted on after HTML already existed. So you can create all this stuff in the DOM, but there's no real linkage to the dynamic environment, JavaScript, and there are no scopes. So that means that you just are basically dumping everything into this global tree that you then have to fish around in using selectors or something to find things. But thank God, HTML is kind of Lispy, so you know what to do. This HTML markup over here, you can see that it's syntactically equivalent to this Lisp markup. I mean, people have suggested S expressions instead of XML syntax for a long time. But what's interesting in ClojureScript is that you can actually implement these things, implement the semantic as well. So in HLisp, div is actually a function which returns a DOM element. And this is all done by the Hoplon compiler, which takes .hl files, and for each one of those, which is a page, the unit of compilation is a page, it emits an HTML bootstrapping kind of minimal file just to load a JavaScript file, which contains all the compiled ClojureScript. And the DOM is actually built at runtime via a program. And the front end compiles to just static HTML and JavaScript, so you could host it on S3 or whatever. So this is an example page. This is kind of what a page normally looks like simplified. But you can actually also do this in HTML syntax. The Hoplon compiler just compiles it all to ClojureScript anyway. So that's cool. You could use your tools, like if you use Haml or something. You could do that. A tricky thing about making HTML into Lisp or Lisp into HTML is how to deal with attributes, which are sort of like metadata on functions in a way, on function calls, rather. And so the way we do it is you could either pass in a map as the first argument or just some keyword value pairs. And it's unambiguous because we know that keywords can't be children of an element. But they don't have to be strings. The values could be other things, which we'll see later. There's no boxing or indirection or virtual DOMs or anything like that. When you call the div function, you get a native HTML div element that you can do stuff to. But the elements implement ifun, which is the protocol to make something invocable in ClojureScript. So, and the invocation semantic of HTML is append child or setAttribute. So we implement that. So you can basically you can construct custom DOM elements, meaning things that have the same semantic as a built-in native DOM element like div or span. But you can construct it yourself and then use it in markup. And so this suggests you can now use functions in place of templates. So no more printf or printf-like things. You're dealing with actual live objects that you can compose in the same way that you compose your markup originally. And those things become essentially custom elements that can then be in your markup, and somebody can use those to build other things. So this is an example of that. We're making a foo element here, which takes any number of children and makes a div with a heading element and then puts the children in. So sequences get spliced in as children. We have this little macro here, which allows you, because it supports two different kinds of attributes, two different syntaxes, kind of, the key value pairs and the map. So in order to deal with that efficiently, we have this little macro that just collects the attributes into a map and the children into a seq, and then calls your body. So this is an example of that. So here we have a quick list custom element, which basically rolls up all of its children into an unordered list and wraps them with list items. And if I set the class on this thing, it gets passed down to the unordered list that it returns. So it's useful. So every page, which is the unit of compilation for this thing, it has a thing sort of like a namespace declaration, except instead of specifying the namespace name, because the page is the end result, you're not going to be using it as a library. So you actually specify where you want the page to reside in your document root. And Hoplon refers in all the things like div span and all the things you want, so you don't have to, painstakingly refer them into your namespace.
May I
Absolutely.
throw something in?
Please.
So Micha pointed out that we include all of those things automatically for you, the HTML5 in particular. sort of built-ins. But we also have an SVG namespace, and some of our more interesting work lately has been working with SVG as if it were a Lisp, which has been pretty interesting. And that stuff is in Hoplon in the SVG namespace.
So here's a sample page declaration. And you can see the refer Hoplon, the second line there. That's basically like refer Clojure. If there's something that Hoplon's bringing in that's annoying you, you can just exclude it. And you won't see the warnings. So like div and span and stuff. DOM, basically, the document object model is an I/O mechanism, input-output. That's the only reason it exists. And events are input. In other words, the user clicks on something. And elements and their properties provide output. You might make something red by changing a property. You might change the contents of a text node. But what's interesting about this is if you think about it in terms of like one-way data flow, input and output never have to mix. So you could have one operation that's setting properties without knowing at all about what events are being listened to and vice versa. So basically, callbacks trigger updates to input cells, meaning I click on a button, that causes some input cell to change its value. We swap on it in the callback. And that eventually may or may not percolate through formula cells to cause an update to the DOM. In other words, some DOM element might be hooked up to wired up to some formula cell, and that formula cell computes that it should be read. So here's an example of that. I'm defining a cell here, an input cell called clicks, whose initial value is 0. This is how many times I've clicked on this button. And then I have a button, and I have the style attribute, which is being hooked up reactively to that clicks cell over here. So I'm making an anonymous formula cell here. And I want to set the color of this thing to be red if the number of clicks is even, and blue if it's odd. Then I set an on-click handler. So here is the callback, which swaps on clicks, adding 1 to it, incrementing it. And then I set the text of this button to inform us how many times it's been clicked on.
And it rules, totally.
And it does things. So what's interesting here is that these attributes, basically they're dispatching on value here. So if it sees a cell as the value, it knows, hook this up reactively to this cell. If it's a function, then it says, OK, this is a callback, so I'm going to treat this, I'm going to look for the click event. And if it's neither of those, if it's a string, then it just sets the attribute on that element. The attributes, these special attributes can be extended. There are 2 multi-methods, doBang and onBang, which handle input and output. So you can add your own fancy things. So here's an example of like the slide attribute. So you can make something like slide up or down. Or the swipe left event. You might hook up to like Hammer.js or something. So you could just implement that with this multi-method. And then you can use those things as if they were already included in Hoplon.
One cool thing about that is that what he just showed, that multi-method, it lets you add attributes to components or object custom elements that you don't own. This differs from Angular, where you can add custom attributes, but it involves scopes and various machinery, and web component specs, which also require that you own the element. So in this example, he's actually teaching elements that had no idea what swipe or any of this stuff is, how to respond to these kinds of events without modifying them. So this is kind of an example of a, what's that like problem? The expression problem, yes. That thing.
And when HTML is a program, which it is here, you can do all kinds of neat things. So here's a function called defValues, which is basically like inlet. You can destructure the binding form and the expression. So this is basically just a thing that does that, but it defines the things instead of binding them locally. So we have a function called tabify, which I'm not showing here. But basically what it does is it takes pairs of things. And if you think about tabs, like on the web, you click on something and it shows the content, certain content, and hides other content, right? And then you click on another thing and it shows the content associated with that tab, right? So there's like an interesting way to generalize this. So if you imagine that the real abstraction here is a number of triggers and a number of contents, and you just want to set a relationship between these things, that when you click on a trigger, the associated content shows itself and the other contents hide themselves. And When you click on the other trigger, same thing happens. So here we have, basically we call this function to tabify these things, but it returns them back. It doesn't compose them. And this is an interesting thing because we've been able to decouple the relationship between the things and their internal state from their composition in the DOM. So the UI guy can use this function to create the tabs kind of relationship between elements, but he might not want to put them into an unordered list here like I did. He might want to put like one trigger way over here and one trigger way over here, and it might not look like tabs at all. It's just essentially a tab-like relationship, and he can express that, and he can make his own custom elements that use this as an underlying lower level thing. So you can progress from simple things to more complex in a nice way. You can also do things like this. So here, a lot of times people will do like div and give it a class red, and that means that it should be red, all the things with class red. But that's like a weird kind of, that CSS, especially with the cascading, is like a weird kind of scoping system and aspect-oriented programming. You're setting up a scope in which, and really the purpose of it is to manipulate properties of objects. Like I want to set the style.color property. So a more direct and powerful way is to actually define a thing called red div. And since all these things implement ifun and they're all invocable, we can just use that in the DOM. And so you can use lexical scope there. Red div might mean a different thing in one context than another. You can use dynamic scope to figure out what color it should be. All the things that Clojure lets you do already. It's more powerful than CSS, I believe. So Castra is the backend that we use. And this is an RPC ring middleware and a ClojureScript client library. It uses EDN back and forth, so you call it like functions on the client, and you give it ClojureScript data. It's pretty much transparent. There's no, you're not making anything be JSON or anything like that. It has affordances for CQRS, state machine pattern, and it's great with Datomic because the CQRS pattern is really amenable to polling, which Datomic is really good at. Like reads are free, so polling is a lot cheaper than if you're calling into like MySQL or something. Here's the picture basically of what's going on in the client. You call this function, goes through our little servlet, our middleware and ring, and the RPC handler looks at authentication annotations, calls an RPC function in your API namespace, and that's basically for side effects only. It's going to manipulate the database in some way. It always returns the same exact query. So if you were a shopping cart site, this query might be, what's your user ID and what's in your shopping cart, say. But that doesn't depend. It doesn't matter what the endpoint was that you called. You call login, you call buy a thing, whatever endpoint you call, it always returns the same exact query. This makes things very simple because now your AJAX call doesn't have to know what to do with the response. It just fires and forgets. All the responses come back to the same handler, which updates the global state of the client. So the API endpoints are just regular functions, but they have these annotations on them, which are similar to Clojure pre and post conditions. This allows you to compose API functions without mocking any state. So it separates the authentication from the invocation. So the authentication only happens when it comes in on the HTTP as an HTTP endpoint. And also exceptions can percolate out to the client and be caught. So this is an example of that. It's a map where you give it a precondition and a query, which is what it returns at the end. And you can call these things from the REPL, and they work just fine. They work exactly the same way. You don't have to mock any state at all. This is an example application of what it would look like. And on the client side, you create generally 3 Javelin cells, one for the state of your little state machine, one for any errors that come back, exceptions, and one for how many, a sequence of currently in progress async calls, because you might want to know if something's still loading or not. You construct the remote endpoints and call them like functions. So basically, there's this make remote function that allows you to construct the endpoint and hook it up to the cells. Then you just call it, like over here, you call it like a function. And you don't have to worry about what it returns. You don't have to, this part right here doesn't have to know how the rest of the application is affected. that percolates up through formula cells automatically. Here's a picture of the architecture of what I just described. Does anyone have questions?
Thumbs up, thumbs down? I don't know. How do we feel? Yes?
Is Castro a little bit like short lead, or
Did you say that again?
is Castro a little bit like short lead, or?
The question is Castro like short lead?
Well, it's an RPC framework, but the annotations that we do to separate all the things that have to do with the session, basically, into a separate layer, that I think that's a little bit different. So like when you're at the REPL, there's no session that you worry about. You don't have to mock anything. And everything runs the same. So you can test things. You can work the app from the REPL, which I do a lot when I'm developing.
Funny side note, the original version of Castro was written in PHP. Is that true? Oh, we won't talk about that.
Yeah.
Sorry. No, other questions? Yes?
You skimmed over like the example code. Can you go back to that?
Sure. This one? No, this one?
Yeah.
OK. I'm sorry we don't have. Let me try and. There we go. All right. So Castro exports this defen macro, which is really the same as defen, but it just implements these, these annotations here. And the precondition, generally, the way we do it is we set up a separate namespace for HTTP rules. And it's basically like Turing complete authentication. You just call this thing just like a precondition, and you can throw an exception from those rules, which will be caught in the client. But that only happens at the actual endpoint. In other words, if I call the login function from the client, it will run this precondition. But if login itself calls another API function internally, like sometimes when you register someone, you want to log them in then, right? So it'd be nice to be able to just call that API function so it doesn't trigger any of the authentication stuff there. It just calls right through. And so the query annotation here is so that you could return that CQRS state query. And this allows you at the REPL, this function could actually return one thing at the REPL, which might be useful for you when you're coding it. But when an HTTP client connects, they get back this state, this state map.
Yes?
And what's the CQRS?
Question was, what is CQRS? I can take that one.
Yeah, please.
Yeah, so all of this is to serve one end, which is basically to be able to conceive of, when we're programming, the server as part of our spreadsheet. So the same way someone who's interested in making charts over an existing spreadsheet can just use the existing formulas without necessarily manipulating any of the data or formulas, we want to look at the server the same way. So in our case here, the server is the source of a value, which is the current user's state. We would like to be able to take that value and aim it at UI elements. Like this little box here should be the person's name, and this should be the number of buddies or whatever. We want to consider the server as like kind of a remote cell. CQRS stands for Command Query Response Separation. Is that ish?
Martin Fowler has a good, well.
Yeah, Martin Fowler has the write-up. Anyway, if you type in CQRS, Martin Fowler, you'll get to one of the source documents. But basically, it's a fancy term for the same kind of pattern, where I have a source of events, which in our case is the user. Those events are streaming into some remote data store, Datomic, and we have formula cells which are calculating the user's state. And those would be Datomic queries. And we periodically want to update the UI based on what we pull from Datomic, but we want to do that in a unidirectional data flow kind of way.
Yeah, I think to think about is like if you have a function that does an AJAX call to the server, like the login function, a lot of times you'll be saying, OK, here's a callback, and if the server returns true, then I'm going to do this. And if it returns false, then I'm going to do that, right? So, but the things you generally want to do is change the state of the application. Like I want to show you an error, a flash message, like incorrect password or something, right? But that means that like this piece of code that sends off the request to login now needs to know about what to do with the response. And it has to know where to go to do that, right? And it has to now cooperate with these other parts of your application. And now imagine that you have 10 buttons on the page, right? And you could click any one of them in any order. So now you run into all kinds of synchronization issues, like, do I need to disable this button when I press this button, and so on. So now all these things have to know about each other very intimately. And then you change something, and you don't know what's going to happen. Whereas with CQRS, things just fire and forget. You send a message to the server, and what comes back is the next state of a state machine, which could actually be the same as the current state. Like nothing might happen on the server that you care about, right? And so then nothing will change. Or something could happen, but you don't need to know about it here. There's something that's looking at our state model and saying, OK, when there's stuff in the shopping cart, I want to show the shopping cart.
Yes?
Can you talk briefly about how that process works? So when you get back a new state, how does that then get reflected in the document?
The question, I think, was paraphrasing how to integrate the server's state with the client state.
Right.
How do we do that?
Like how does it get into the, how is it reflected in the document is what you want to know.
Right. So
Right.
I mean, in David Nolan's talk yesterday, that was using React, where they're figuring out this sort of operations. Are you re-rendering the entire document? What's your strategy?
Right. Yeah, I can go for it.
Yeah.
Yeah, so in general, there are two approaches to doing this thing that we need to do. And I think React represents one approach, and everything we're showing you represents another. The basic bifurcation is between two ways to repaint the UI. One is faster, one is slower. One may or may not be inconsistent, one is guaranteed to be consistent. Those are the trade-offs. The React approach is the same one that Angular uses, but slightly refined. It's called dirty checking. And historically, people who have been writing UIs using this approach, I think there's a common list system called Garnet, or there's whatever, there's papers, check them out. The thing you get is speed, because you don't need to check everything that you're trying to update for equality. Like that's the essence of data flow is we spin through these values that are coming in, and if they're different than ones we knew about, we need to do stuff. With dirty checking, you just say, hey, if anything in the tree changed, we know that stuff below, we're just going to blow away anything that existed below it without checking it for equality. So you get speed there. On the other side, which is what Javelin does and which is what spreadsheets do, we do equality checking for every value that gets pushed in. And we don't calculate diffs. There's really no, the same way there's not really a concept of a diff in a spreadsheet, there isn't in Javelin. What we've found in our efforts around this, and the reason we went with spreadsheet-style data flow instead of dirty checking, is that you need to be able to write components that compose with each other under a semantic. Like, the reason we invented this whole thing is because we had a product with a front end. And we had it was for a meal delivery application. We needed to rebrand well, actually, this is stuff Micha worked on before I joined on. I just showed up at the very end and took all the credit. But it was an application. It was like a 10 billion line PHP jQuery shenanigan. And it had all the logic in it encoded, obviously, but it was impossible to maintain. And then the requirement came down, hey, take this business logic, but let's white label it. Like instead of this being meals for this demographic, we want to ship meals to these people. Is that possible? This came down to Micha, and I guess your short answer is no, it's not possible to pull anything reusable out of this app because the logic and the view are just so deeply intertwined.
Yeah, and I think to point out also is that, so about the dirty checking, the way Javelin works is you can imagine a graph of cells, that are kind of organized by their relationships to each other. In other words, a formula cell might it might refer to other cells. So that forms a graph, but it's this directed graph. And no cell will trigger any updates if its value doesn't change. So there's very aggressive pruning that goes on just naturally. In other words, if an input cell changes, it might cause one formula cell to change. But if that's where it ends, then that's where it ends. So if you have a lot of DOM elements that are looking at all these other formula cells, nothing happens because no values changed. However, if the values did change, then you definitely need to update those DOM elements anyway, no matter what, because they're no longer, consistent. So I think another thing to look at comparing these two approaches is I look at the DOM as this input-output device. And React seems more to me like a buffer, kind of like Emacs. You can type around in Emacs, and Emacs has, I'm sure, all kinds of clever tricks to avoid repainting the entire thing when you type. But it's still, the abstraction is still a buffer, that's a sequential thing. The DOM is a little bit richer than that in that it gives you kind of more like a file system of buffers. You have this tree of buffers that you can kind of read from and write to individually, right? And so now you can be treating each DOM element as a buffer. and doing things to them individually. And once you have, if you're working with the DOM element itself, right, unlike everything involving I/O is stateful. When you have a file handle, that's a stateful thing because you might write to it and it needs to keep track of its buffers. It needs to keep track of whether things are flushed to disk or whether you could read from it or write to it or what. So DOM elements actually act the same kind of way. And so you can do like in that tab example where you can pass DOM elements to a function that doesn't know what they are at all. And they just apply magic to them. And then these DOM elements remember the magic. In other words, attaching an event handler to something is a mutation because it has to keep track of what it needs to notify. So that's a very powerful thing when you're working with the actual DOM elements because you pass them to this one function that just arranges some relationship between them and passes them back. You pass them to something else. You might be mixing elements around, and then you compose them later. So you're not bound to any particular composition of them.
I think actually we're out of time. I think we should leave you with what Micha just said, which was remember the magic. That sounds cool. But we'll be around if you have questions, want to chat. Hoplon.io is the place to go and learn. Thank you so much for your time. And thank you, Alex, and everybody else.